This is the title of the machine learning problem I'm tackling. I'll be focusing on a specific part of Sklearn, which is a popular Python library for machine learning, related to feature selection. Specifically, I'll be looking at how the SelectorMixin class works. Here's the core question. I need to pick which statements about SelectorMixin from Sklearn's feature selection tools are true. I'm given multiple choice options which are statements. My task is to identify the correct ones regarding SelectorMixin. This statement says SelectorMixin has a transform method. I will determine whether it's correct. This claims SelectorMixin is a base class, meaning you can't use it directly. You need a more specific version of it. This statement suggests that SelectorMixin needs a fit method before you can use the transform method. I'll check if it's accurate. This statement says SelectorMixin automatically selects the best features. I need to verify if this is true. This section explains what knowledge I need to solve the problem. It highlights that I need to understand SelectorMixin as a base class, and the roles of the fit and transform methods within feature selection in machine learning. This section points out that I need to use my knowledge of Sklearn's documentation and the general behavior of SelectorMixin and its related classes to solve this. No complex calculations are involved. It's all about understanding the concepts. I see that option A says the transform method applies a selection mask. That's correct. The transform method in Sklearn's SelectorMixin takes the features selected during the fit step and applies them to your data. It's like taking a stencil and only keeping the parts of the picture you want. Option B states that SelectorMixin is a base class you can't directly use. That's also true. Think of it like a recipe template. You need a specific recipe, like SelectKBEST or SelectPercentile, before you can bake a cake, perform feature selection. Option C says a fit method is needed to determine feature importance before using the transform method. Absolutely. You have to teach the model what features are important, fit step, before you can use that knowledge to select features, transform step. It's like learning the rules of a game before you can play it. Option D claims SelectorMixin automatically picks the best features. I disagree. SelectorMixin is just a framework. The specific algorithm you choose, e.g., SelectKBEST, determines what's considered most important. It doesn't make those decisions on its own. Think of it as a toolbox. You provide the tools, and the toolbox doesn't decide how to use them. I see you're working with Sklearn's SelectorMixin, a crucial component for feature selection in machine learning. It's like a toolkit that provides a standard way to select important features from your data, preparing it for your models. This statement is true. The transform method is where the magic happens. After you've identified which features are important, using the fit method, the transform method applies those selections to your data. It's like using a stencil to keep only the parts of the picture you want. The input is your feature matrix, all your data's features, and the output is a transformed matrix, only the selected features. That's correct. Think of SelectorMixin as a blueprint, not a finished house. It defines the structure that all specific feature selectors will follow. However, you can't use the blueprint directly. You need a specific feature selector, built upon this blueprint, like SelectKBEST or SelectPercentile. Absolutely true. Before you can select the best features using the transform method, the fit method needs to assess the data, and then figure out which features are most relevant to your problem. It's like a chef tasting the ingredients before they start cooking. This is FALSE. SelectorMixin just provides the framework. The actual definition of importance depends on the specific feature selection algorithm you choose. SelectorMixin itself doesn't make that judgment call. This refers to the table of data you provide to the feature selection algorithm. Each row represents a data point, and each column represents a feature. This is a way to select features that will be used in the final model. It's like a list that indicates which columns are selected, often represented as a Boolean array. The result after applying the selection mask to your feature matrix. It contains only the selected features. This is the method called to learn the feature selection criteria, the learning part. It is akin to training a model. This method applies the learned criteria obtained in the fit method to select the features for your model. It's the application phase. I'm going to explain how Sklearn uses SelectorMixin for feature selection in machine learning. SelectorMixin is a crucial tool that helps you pick the most relevant features from your data, improving your model's accuracy and efficiency. Think of it as a smart filter for your data. This is the core question of the quiz, focusing on your understanding of SelectorMixin's functionality within Sklearn's feature selection module. This statement is correct. SelectorMixin has a transform method. This method uses a mask. Think of it as a template to select only the features you've identified as important. The transform method then applies this template to your data, keeping only the selected features. This statement is also correct. SelectorMixin is a base class, like a blueprint. You can't directly use this blueprint to build something. You need a concrete class that inherits from SelectorMixin, like SelectKBest. This concrete class provides the actual implementation for feature selection. Another correct statement. The fit method is where the magic happens. Before applying the selection, SelectorMixin uses its fit method to learn which features are the most important. It analyzes the data to determine this, and it needs to learn before it can transform the data effectively. This statement is false. SelectorMixin doesn't inherently know what makes a feature important. The specific algorithm you use with SelectorMixin, like SelectKBest, determines which features are selected. SelectorMixin only provides a standard way to use these algorithms. I see that you're looking at SelectorMixin SelectorMixin isn't something you can use directly. Think of it like a recipe for making a cake. It gives you the basic instructions, but you need a specific cake recipe, like SelectKBest or SelectPercentile, to actually bake a cake. You need a subclass. It's a base class, a foundation for other classes that build upon its functionality. You must use another class that inherits from it. The fit method is where the magic happens. Before SelectorMixin-based feature selectors can choose the best features, they need to learn which ones are important. The fit method does this learning process. Think of it as training a dog. Before the dog can perform a trick, you need to train it. Similarly, before your feature selector can choose features, it needs to be trained with the fit method. Once the fit method has learned what's important, the transform method is what puts that knowledge into action. It applies the learned selection to your data. It's like taking your trained dog and actually having it do the trick you trained it to do. It takes the selection criteria that were learned in the fit method and applies them to your dataset, keeping only the features that were deemed important. I confirm that SelectorMixin in Sklearn is indeed a base class. You can't use it directly. Think of it like a blueprint. You need a specific implementation built from that blueprint to actually do anything. For example, SelectKBest or SelectPercentile are concrete classes built upon the SelectorMixin base class. Yes, SelectorMixin provides a transform method. This method is key because it's how you apply the feature selection that the fit method already learned. You give it your data, and it uses a selection mask, basically a list of which features to keep, to return only the selected features. Absolutely. A fit method is essential. The fit method is where you essentially teach the selector which features are important. It uses an underlying algorithm, like chi-squared or F regression, depending on the subclass used, to determine feature importance and generate the selection mask that the transform method will later use.